Hi guys, in this video we are going to be looking at differentiation of common functions. Now the rule of differentiation is if you are given a function y equal to ax raised to power n, then the derivative, which is after differentiating, the derivative of that function is equal to a times n x n raised to power minus x raised to power n minus 1. Now the rule is you bring down this n, multiply it by a, then you minus 1 from the n, which is what you can see here. Now, if it doesn't come in this form, it either comes in this form, which is f of x is equal to a times x raised to power n, where the derivative is f prime of x. This is prime, f prime of x is equal to a times n times x raised to power n minus 1, which is bringing n down, multiplying it by the full function and minusing 1 from, or taking out 1 from the power. And this is true for all real values of a and n. And we can see from example here, we are given this y here, this function y equal to 4x cubed, where our a here is the 4. This is our a, and this 3 here is our n. Like I've said, the derivative is equal to a times n x n minus 1, which we have seen here. The a here is 4, like we have said in the rule, and the n here is 3. And you can see I have minus 1 from 3, and 4 times 3 is 12, then x squared, and this is the derivative of this function. So we have finally, or we have actually differentiated this function. And what about if the power is 0? If the power is 0, follow the same step, bringing 0 down. And if you multiply 0 and taking 1 out of 0, well, if you multiply 0 by this function, you get 0. So if the power is 0, the answer comes out to be 0. Now, this can be said that if you are given a function f of x, which is equal to p of x plus q of x minus r of x, where f, p, q, and r are all functions of x. If they are all functions of x, we can see that the derivative is f prime of x is equal to p prime of x plus q prime of x minus r prime of x. And I will explain this using this example below. Now you have given a function f of x equal to this. Let's say this is our p of x, this is our q of x, which is 4x cubed, and our p of x is 3x squared, and our r of x is 2x. And we can see that differentiating this function, we get f prime of x, and our p prime of x will be the same rule which we said earlier, bringing our 2 down here and saying 2 minus 1, which is what I've done here, bringing the 2 down here and 2 minus 1. Same thing goes to the q of x. I brought my 3 down, multiplying it by the 4, then I minus 1 from it, from my 3, the power here, minus our r of x. Then the r prime of x will be 2. Remember, there is nothing here, so it is 1, because anything raised to power 1 is that same thing. 10 raised to power 1 is 10, 5 raised to power 1 is 5, 2 raised to power 1 is 2, is still 2. So anything raised to power 1 is that same thing. And so we put the 1 minus 1. Now here we get 3 times 2, 6, and 2 minus 1 is equal to 1. Just as I've said, anything raised to power 1 is still 1, and that's why x is here. Then here 4 times 3 is 12. Then 3 minus 1 is 2. Then here 2 times 1, the one I brought down, is 2. Then why is x not here? 1 minus 1 is 0. And anything raised to power 0 is 1 from the laws of indices. Anything raised to power 0 is 1. 100 raised to power 0 is 1. 5 raised to power 0 is 1. 10 million raised to power 0 is 1. So let's look at some examples. Let's solve some examples on this. And we can see the example 1. We are asked to find the differential coefficient of y equal to 4 divided by x cubed. Now, what I advise mainly is to break this down to easy form that we can understand. And I would like to show us that this is equal to 4 times 1 over x raised to power 3. Now, from indices, we know that this is 4 times x raised to power negative 3. 1 divide represent this negative, and this is our power here. So, and this is easier to understand. Y is now equal to 4x negative 3. And so we can now differentiate this with ease using our rule that we just learned of differentiation. So we can say that the x is equal to an xn minus 1, where our a is equal to 4 and our n this time is equal to negative 3. So this is 4 multiplied by negative 3, then x negative 3 minus 1. And we can see that this is negative 12x and this is negative 4. And so we can rewrite this to look like this form by saying, separating it again, negative 12 multiplied by x raised to power minus 4, which is what I did here. Then it's the same thing as saying negative 12 multiplied by 1, which is this negative here, divide x raised to power 4. So this negative here is represented in indices as 1 divided by this. And so my answer comes out to be negative 12 times 1 to be negative 12 over x raised to power 4. And this is my answer. So the second one, we're asked to find the derivative of y equal to 3 square root of x. Y equal to 3 square root of x. And like I've said, we can still separate this to say 3 times square root of x, which is still equal to 3 times x raised to power half. Now this is from the knowledge of indices. When you have 1 over 2, it means that this 1 is the power and this 2 is the root. Like here we just have only 4. We don't care what the sign might be, because we already know that the sign, if it is negative, it is 1 divided by then the variable given to us. So, but this is positive. So, and we have 1 over 2. It means that this one is the power, and we can see from here, x is raised to the power of 1. And here is the root 2, which is the square. So this represents the square root. And we can say that this is equal to 3x 1 over 2. And now you see, we can work it out by saying that our derivative, the y, the x, is equal to an xn minus 1, where our a is equal to 3 and our n is equal to 1 half. So applying this rule, I will say 3, which is a, multiplied by half x raised to power half minus 1. Now, if you do your mathematics, you will see that 3 multiplied by 1 over 2 is 3 over 2. and 1 half minus 1 is negative 1 half. So this is the same thing. This is our answer. We can either leave it in this form or rewrite it in this form. And we can say it is equal to 3 over 2. Now there is a negative sign here times 1 over, which is this negative sign, x raised to power half. Now this is still equal to 3 over 2 times 1 over, we see this is the power and this is the root. So the power is x raised to power 1 and the root is square. So this is a square and this is our answer. 3, 2, oh sorry, this is x and this is our answer. So let's look at the B part of the number 2. The B part of the number 2, we are asked to find the derivative of y equal to 5 over the cube root of x raised to the power of 4. Now, like we break it down, this is 5 multiplied by 1 over the cube root of x raised to the power 4. And this is the same thing as saying 5 multiplied by 1 over x 4 over 3. Now, recall I said in this example here that this one is the power and this 2 is the root. So the same applies to this here. This 4 is the power and this 3 is the root. So this is our knowledge from indices, and I can write this to be 5 multiplied by x. We recall what this is. This is negative here, 4 over 3. So we can now work with this. This is very easy to work with. And so solution, the y dx is equal to an x n raised to power, or x raised to power n minus 1. Our a we see from here is 5. Then our n is equal to negative 4 over 3. Just the same way our n here is equal to half. So our n is negative 4 over 3, and we can apply it. 5 multiplied by negative 4 over 3. Then our x, then we have negative 4 over 3 minus 1. And now we can say that this is equal to 5 multiplied by 4 is equal to 20. Negative is still there. Divide by 3. Multiply by, if you use your LCM here, you discover that x is raised to the power of negative 7 over 3. Now, we can rewrite this to be equal to negative 20 over 3 multiplied by 1 divided by, which is this negative, 1 divided by x raised to the power 7 over 3, which is still the same thing as negative 20 times 1, negative 20. And we can rewrite this 3 times all this is 3. We can write this to be the cube root, which is the denominator here is the root, the cube root of x raised to the power 7, while the numerator is the power, x raised to the power 7. So this is how we break and arrange a function like this. So now the third question here is to Find the dy/dx of y is equal to 4x squared plus 1 over x squared. Now we can solve this individually. We know that this will give us, okay, solving this individually, let's say y is equal to 4x squared. This is 8x. Now this is our answer for this. Sorry, dy/dx or dy/dx of this is equal to 8x, while the dy/dx of this, where y is equal to 1 over x squared, dy/dx of this is equal to, now we break this down to x raised to power negative 2. This is what we have, and we get negative 2x negative 2 minus 1. So this is 1 here. So negative 2 here multiplied by 1 will give us negative 2. And negative 2 minus 1 will give us our dy/dx to be negative 2 x raised to power negative 3. And now we can see, putting this together, our sign here will change because this is no more a positive. The derivative of this is no more a positive. So our dy/dx is simply equal to 8x, which we got from this, then negative 2x raised to power negative 3, which we can rewrite as 8x negative 2 divided by x cubed. And this is our answer.